Hi students, welcome to my physics classes. Today we will discuss ray optics 3 reflection of light. In this I am going to discuss about plane mirror and the characteristics of image in case of plane mirror. To understand this there are some basics these you should know. Object can be defined as the combination of incident rays gives object or point of intersection of incident rays. Image can be defined as the combination of reflected rays or point of intersection of reflected rays gives image. Let us see how object and image will be located in case of plane mirror. Let us suppose this is a glass surface. I silvered one side or polished one side. Automatically another side reflections are possible, so that now it will act like a mirror. Imagine any point object there in front of the plane mirror. O is the object. We know from the object light incident and reflection takes place. Minimum two rays are required to locate image inside the mirror. So that I draw two rays. This is incident ray I1. I want two rays to locate image inside the mirror. I2 incident ray. We already discussed in previous videos, that is about laws of reflection. Light follows laws of reflection, either it is a plane surface or curved surface. Can I say this is normal? Yes, this is normal. And over here also it is normal, normal, normal. From the normal, with the same angle, it will take reflection. As a result, I got R1, reflected ray 1. And here also, ray taking reflection, this is R2, I2, R2. Actually, if you observe, R1, R2 is moving away from each other, means divergent beam of light. They are moving away from each other, so that the combination will never happen in front of the mirror. So that I have to extend these reflected rays backward. What happen we will see. If I extend backward, R1 and R2 also, what happened? The combination of reflected rays I got here. As a result, it will be treated as a image. Combination of reflected rays gives image. This is image, combination of reflected rays. Combination of incident rays gives object. Object, combination of incident rays. In this situation, the image is considered to be virtual image. Image is virtual, but object is real object. Very important to recognize, whenever the object is real, image is virtual, and whenever the object is virtual, image is real. Very simple to understand. Whenever you draw the rays backward, actually reflected rays are moving this way, divergent beam of light. Whenever I draw this backward, I got image. So that in this situation, this image is treated as a virtual image. If the rays are meet, actually, if you observe the combination of incident rays, actually looking like coming from this point, so that real object. That's it. Next, we will discuss characteristics of image in case of plane mirror. Before going to that, you should know, if you observe this diagram, image is virtual. Image is virtual. Object is real. Now I will draw diagram for the real image and virtual object. After that we will discuss characteristics of image in case of a plane mirror. Imagine mirror. rays are coming from infinity distance. Here, these rays are considered to be virtual rays. Rays are virtual rays. Minimum two rays are required to locate image, so that I draw another ray this way. If you observe, these two rays are virtual rays coming from infinity distance as acts as incident rays. From the normal, reflection takes place. The rays is going to reflect, and here also reflection takes place. I1, R1. Suppose this is the I2, R2. If you observe R1, R2, combination of reflected rays gives what? Combination of reflected rays gives always image. If you observe, these rays are actually meted here, so that now the image is considered to be real image. Image is real. These are the incident rays, combination of incident rays. They are looking like coming from somewhere else and they are going to meet somewhere else. If you observe, this is a convergent beam of light. Whenever I extend these incident rays forward direction, definitely these two rays are going to meet. Yes, these two rays are going to meet here. As a result, I got object. In this situation, object is considered to be virtual object. Object is virtual. If you observe, compare these two diagrams. Here, image is real. Object is virtual. From this, we can understand that if the object is real, image is virtual. If the object is virtual, image is real. This is one of the characteristics in case of a plane mirror. Now we will see in detail what are the characteristics of a image in case of plane mirror. Image characteristics, plane mirror. Take a look at the diagram. There is a plane mirror. In front of the mirror, there is a candle as object. Object is candle. From the candle, the rays are moving forward direction. If I select this edge, I can able to locate this object's image inside the mirror. If any ray incident normally means angle of incident over here is 0. We already discussed angle I is equal to angle R. Angle of incident and reflection remains same. I is equal to R, 0. Ray incident, normal incident and reflection takes place. I can able to extend reflected ray backward. Minimum two rays are required to locate image. If I select another ray from the same edge, if any ray incident is some angle theta from the normal, it is moving symmetrically opposite direction because light follows laws of reflection. It is taking reflection from the mirror. If you observe this ray R1, this ray R2, divergent beam of light. Whenever I extend these rays backward, I got image. So this is the image edge. I selected image edge. So in this way you can able to locate image very clearly. Object distance from the mirror. Distances are always measured from the mirror only. Object distance from the mirror is U. U is the object distance. Image distance from the mirror is V. V is the image distance. Let us suppose H suffix O, height of the object. H suffix I, height of the image. If you observe, by extending these rays, I got image. So that in this situation, image is considered to be virtual image. But object is real object. Object is real. First character. Can I say object distance and image distance remain same? Yes. distance of object u is equals to distance of image v, distance remains same. Second character, height of the object, height of the image remains same, obviously same. Height of the object is equals to height of the image. Second character. Third character, images formed by a plane mirror always virtual and erect. Yes, images formed by plane mirror always virtual and erect. Virtual image, erect image. Erect means upright. Head as head, top as top, bottom as bottom, like this, upright. Fourth character, can I say images forward by plane mirror are laterally inverted. Images taking lateral inversion. Images formed by a plane mirror are laterally inverted. This is the concept of lateral inversion. I will discuss about this. For that, imagine any plane mirror. There is a plane mirror. In front of the plane mirror, I am going to keep my left hand like this. Suppose these are the left hand fingers. For that, inside the mirror, you will find the fingers like this. It is looking like right hand. Actually, I put my left hand here. Left hand. For that, you feel that inside the mirror as right hand. So this is the concept, nothing but lateral inversion. Or please observe this diagram also. We have a set of capital letters ABC. There is a plane mirror. If you want to observe these letters inside the plane mirror, it is looking like this. C, B, A. If you observe over here, B and C are clear cut laterally inverted, but we cannot able to observe A is laterally inverted, but actually lateral inversion takes place, but we cannot able to observe clearly about A. This is the concept of lateral inversion. Finally, lateral inversion means whenever you are looking your face, looking yourself inside the plane mirror, you feel that left as right, right as left. That's it. That is nothing but lateral inversion. Now we will discuss magnification of a plane mirror. Magnification in case of a plane mirror. Next character 5, magnification. M is the magnification, defined as the ratio of height of image unto the height of object. Height of image unto the height of the object, or the ratio of image distance unto the object distance, V by U. This is nothing but magnification. What is the height of image? For example, height of object given as 1 centimeter and image also 1 centimeter. Why? Because characteristics of a plane mirror, height of image, height of object remains same. So 1 by 1 will come. Object distance, image distance also remains same. Suppose the distance of object given 2 centimeter, image distance also 2 centimeter from the plane mirror. 2 by 2 I will get 1. So finally magnification is equal to plus 1. Magnification of a plane mirror always considered to be plus 1. So very important, magnification of a plane mirror always plus 1. And one of the character I already discussed earlier, that is, if the object is real, image is virtual and vice versa case. That is one of the character. Sixth character. If object is real, image is virtual and vice versa. There is important note you must remember. Suppose there is a curved surface. By common sense, I can able to draw complete circle. I can able to locate center here. No problem. Can I say distance from center unto the circle, unto the line of the circle is nothing but radius. You can able to find radius, locate radius here. Suppose there is a straight line given. Can you able to find radius here? Not at all. I cannot able to find radius here. I want to search radius. Where is radius? Still infinity distance you have to search. Notice here, radius of curvature or focal length in case of a plane mirror is at infinity distance. Note, radius of curvature or focal length for plane mirrors is infinity. A very important note. R and F for plane mirror is infinity. I hope everyone enjoying my physics. Now we will discuss some applications of image in case of a plane mirror. Firstly, I will discuss rotating plane mirror. Rotating plane mirror. Source is fixed. Incident ray remains fixed. If mirror is rotated by an angle theta in anti-clockwise direction, then reflected ray rotated by an angle 2 theta. We have to prove this result. Mirror rotated anti-clockwise direction with an angle theta. I want to find reflected ray must be rotated with an angle 2 theta. Now see, we already know angle of incident and reflection remains same. Angle between incident ray and to the normal, angle of incident I is the angle of incident. Angle between normal and to the reflected ray, angle of reflection R. Since I is equal to R, so that let I is equal to R equal to I. Angle of incident equal to angle of reflection. I move with I. Suppose I rotate the mirror in anti-clockwise direction by an angle theta. Please observe very carefully. I rotate this way. Let Mi initial position of the mirror, M suffix F final position of the mirror. Actually, I rotate the mirror anti-clockwise direction by an angle theta. This is also has to be theta. Initially, normal always perpendicular to the plane. Initial, this is normal. Initial normal. Now mirror rotated by an angle theta, so that normal also rotated. Obviously, now it become new normal. This is new normal. I name this as N dash. N dash is the new normal. Now if you observe, angle between incident ray, source remains fixed. Angle between incident ray and to the new normal is nothing but angle of incident. Can I say this is I minus theta? Why? Because mirror rotated by an angle theta, normals also moved by an angle theta. This is only way to observe. Yes, obviously it is correct. Normals also rotated with an angle theta. Now initial normal, angle of incident with initial normal I, with a new normal, angle of incident is total I, you have to subtract this theta, so I minus theta. Now what happened? From the final position of the mirror, we can also observe reflected ray. Yes or no? Can I say this is reflected ray? After rotation of the mirror, R dash reflected ray. I want to find this angle. Let us suppose this is X. X is the angle what we are going to find. Can I say angle between new normal and to the new reflected ray is nothing but angle of reflection? Yes. So this become I minus theta. New angle of incident I minus theta. New angle of reflection between N dash and R dash I minus theta. This total I. Nothing is there for this. Suppose this is Y. I name here Y. Now can I write Y as Y is equal to Y I minus theta, and here to here this angle associated between R dash and N dash I minus theta. I want to find Y I minus theta minus theta. I minus theta minus theta, so that I will get Y. Y can be written as I minus theta minus theta or I minus 2 theta. This is Y. Now if you observe X, X is the angle. Actually reflected ray, initial reflected ray, that is I associated with initial normal I. Can I say I X is equal to I minus Y? This is I. You have to subtract this Y. X is equal to I minus Y. But what is Y? If I substitute where Y is I minus 2 theta, I minus Y is I minus 2 theta, I minus 2 theta, I minus of plus minus I plus 2 theta. I and I get cancelled. Finally I got here X is equal to 2 theta. Now we have proved this. Total deviation formed by the combination of two plane mirrors kept inclined. Let us imagine there are two plane mirrors kept inclined manner. We have to find total deviation of combination of for these plane mirrors. This is incident ray, incident on the mirror M2. Light follows laws of reflection. Angle of incident and angle of reflection has to be same. Let us suppose I is equal to R is equal to theta here for the mirror M2. So I can move with theta 1. For M2, mirror M2, I equal to R equal to theta 1. And for M1, I is equal to R is equal to theta 2. So change this better. M1, this is M2. For M1, I is equal to R is equal to theta 1. For M2, I is equal to R is equal to theta 2. Theta 1, theta 1. And here theta 2, theta 2. Light follows laws of reflection. If I extend this forward direction, this angle of incident forward direction, I know angle between incident ray and to the reflected ray. For the first mirror, this is reflected ray. Angle between incident ray and to the reflected ray is nothing but angle of deviation. Deviation formed by a first mirror become what? See carefully. Can I say this is glancing angle alpha, angle between reflector and to the incident ray alpha? If this angle is theta, this is also theta. This has to be alpha. Suppose this is 30 degree, theta 1 30 degree. Here also it become 30 degree. 30 plus 30 60. Alpha is 60. Again alpha is 60. Total 180 degree. If it is alpha, it has to be alpha. Vertically opposite angles. This is alpha. This is also has to be alpha. Alpha, alpha. Now we can observe total deviation. Total deviation formed by a first mirror to alpha. Alpha plus alpha to alpha. And for the second mirror, if I extend these reflected ray from the first mirror act like a incident ray for the second mirror. If I extend this forward, this become angle of deviation formed by second mirror d2. Incident ray for the first mirror, second mirror, incident ray, reflector. Let us suppose this is beta. This has to be beta. 90 degree, 90 minus theta 2, 90 is equal to beta plus theta 2. Beta is equal to 90 minus theta 2. Over here also we can observe 90 is equal to theta 2 plus beta. Beta is equal to 90 minus theta 2. Beta, same beta. Vertically opposite angles. If this angle beta, this angle also has to be beta. This is also beta. What is total deviation? d2 to beta. Now deviation total. Deviation total d1 plus d2. d1 is 2 alpha plus d2 is 2 beta. If I take 2 common, you will get alpha plus beta. If you observe the triangle, suppose I name x, y, z is a triangle, x, y, z. Theta plus alpha plus beta gives 180 degrees. From the triangle x, y, z, theta plus alpha plus beta is equal to 180 degree, or alpha plus beta is equal to 180 degree minus theta. I can use this result where alpha plus beta is 180 minus theta. Now put here 2 into 180 minus theta. If I multiply it, 360 minus 2 theta you will get. This is deviation total. Total deviation formed by a combination of two plane mirrors formula. Here alpha, beta are the glancing angles. Let alpha comma beta glancing angles. Thank you. Please subscribe.